Today we're looking at how to solve equations that are in quadratic form, meaning they have an x squared to them. Now, we've seen this where we set it equal to 0, factor, set each of the factors equal to 0. But what happens if we see things that don't factor? And so we're going to need some other techniques to solve equations that don't factor. And the square root method is one of those techniques. It's actually a pretty slick technique, but it only works some of the time. Here are the basic steps that we're going to follow to use the square root method. It's very similar to how you would solve an equation with a square root in it, because squares and square roots are opposites of each other. So the first thing we're going to do is get the squared parts by itself. So whatever's being squared, we're going to put on one side, and anything not being squared has to go on the other side. And then you're going to get rid of the squared bit by doing the opposite of that, which is square root. So you'll take the square root of both sides. Once you've got that done, you're going to be able to solve for x using some old algebra skills. Now, there's two things to remember when doing this. Number one, this only works when you can get the squared part by itself and there are no other variables involved. If you isolate the squared part on, say, the left side of the equation, but then there's still an x hanging out on the right side, this technique's not going to work. You're going to have to do something else. The other thing that I want you to remember is whenever you take the square root of both sides of the equation, you have to account for the fact that when we square things, we might lose the negative sign. So whenever you square root both sides of an equation, we're going to have to use the positive and the negative versions of what we're doing. Let's give it a try. First, will it work here? Could I get the squared part by itself, and is that the only x? So here's the squared part, and there are no other x's, so I think we're good to go for this technique. First things first, we've got to get the squared part by itself. So I'm going to move that 6, because he's not being squared, to the other side. So let's subtract the 6 over. That would leave me with negative 5x squared on that side and negative 40 on that side. I'm actually not done with step 1 yet. The part that's being squared is just the x. This is negative 5 times x being squared. So we need to move the negative 5. It's being multiplied, so we move it with division. And they were going to cancel out and leave us with x squared. And divided by a negative is going to be positive 8. So we're getting very close. We have isolated the squared, and everybody that was not being squared is on the other side. Next, we are going to get rid of the square by doing the opposite of squaring, which is square rooting. So I'm going to square root both sides. And the reason that works is the square root of x squared is just x. But what you do to one side of an equation, you have to do to the other. And anytime you square root both sides, we need to account for the fact that we may have just lost a negative somewhere. Okay, so we've got x equals, and on the other side we have plus or minus the square root of 8. Well, the square root of 8 is something that could be simplified because it's 4 times 2, and 4 is a root we can do. So my final answer is plus or minus 2 root 2. And this is a completely acceptable way of writing that answer. But I want to make sure that we understand we really do have two answers sitting there. You could also write it 2 root 2 and negative 2 root 2. That's really what we're saying when we're saying plus or minus root 2. So either way you want to write your answer is fine. But it's important to understand that when we write this, we really mean this. It's got both answers, a positive and a negative. Let's see if we can use that same technique on example 2. Now the squared part is a little different here. It's not just the x. the thing that's being squared is x plus 6. Could we get it by itself? Yeah. Are there any other x's? Nope. I've got a 2, an 11, and a 5. So no other x's, so I think that technique is going to work just fine here. So the first thing we're supposed to be doing is trying to get whatever is being squared, which would be that bit right there, by itself. So I'm going to move the 11. I'm going to have 2 times that thing being squared. And on this side, we're going to get negative 6. Not done with step 1 yet. I still have something that's not being squared on the left side. It's that 2. Since he's not being squared, let's move him to the other side. Okay, we've got the squared part by itself. Next, we are going to square root both sides. But whenever you square root both sides, don't forget a plus and a minus in there. Now, the square and the square root are going to cancel and leave us with x plus 6. Over here, I've got plus or minus. Remember, when we do square root of negative, that's going to be imaginary root 3. We are really close. This is the first one where we have to do a step 3. We've still got to solve for x. To get x by itself, we're going to minus that 6 over. So x is now by itself. Be careful on the other side. These are not like terms. This is a real number and this is imaginary stuff. So we need to write our answer as negative 6 plus or minus I root 3 because we cannot put those two things together. Keep in mind, we still have 2 answers. So one way to write it would be like that. You could also write it as negative 6 plus I root 3 and negative 6 minus I root 3. Same thing. Either way is totally fine. Let's try one more. Can we do this? Well, let's see here. I'm trying to get this squared part by itself. So I'm going to have to move this negative 4 and this 3. But there's no other x's, so I think we're good to go. So let's move that 3. It's now being divided, so we're going to multiply both sides by 3. Because this is like 3 over 1, and then these would cancel out. And 3 times 16 is 48. Okay, to get the squared part by itself, I still got to move one more thing. It's that negative 4. It's being multiplied, so we're going to divide. And this is going to be negative 12. Okay, I've gotten the squared part by itself. Time to square root both sides. And whenever you square root both sides, you're going to remember that plus or minus. The square and the square root's going to cancel and leave me with 2x minus 4. On the other side, that's something we could simplify. Think about negative 12 under a radical. That's going to be negative 1 times 4 times 3. The 3 is going to stay in, but the 2i is going to come out. And don't lose the plus or minus. So 2i root 3, I've got positive and negative. Solving for x is a little more intense here. I'm going to add the 4 first. So let's add him over. We'll get 2x equals 4 plus or minus 2i root 3. And then I've got to divide by my 2. I'm going to run out of room. Let's come over here. This is going to give me x equals 4 plus or minus 2i root 3 all over 2. We're not done yet. Do you see why? I think there's a GCF up top that would help us reduce this. I'm going to pull a 2 out of the top. 2 goes into 4 2 times. If I take a 2 out of this imaginary term, I'm going to have I root 3. then I can reduce this 2 with that 2 because that's a greatest common factor 2, so he can be reduced. So that's going to leave me with x equals 2 plus or minus I root 3. There's a 1 on the bottom, so I don't need to write that. Again, we could write this two ways. You could write it this way, or you could write it 2 plus I root 3 and 2 minus I root 3. Same answer. Either one is totally fine. Now, like all math problems, we can do this a lot of different ways. This was probably the best way to handle this problem, but if you hadn't thought of this, you could have FOILed this, 2x minus 4 times 2x minus 4, and then pulled the negative 4 in, and then divided everybody by 3, and then moved this 16 over to set it equal to 0, and then tried to factor it. The bad news is actually all of that work would have ended with you realizing you couldn't factor it. But there are other ways to do this problem, and we'll see it in future videos.